Okay, two more videos in this chapter. Okay, this is the learning target number 6 video. I can zoom in a little bit. It is, I can apply the properties of operations to generate equivalent expressions. Okay, now that learning target for most of you is very difficult probably to understand. Hopefully you can understand what we're doing. We actually already had this learning target earlier in the year. So we're going to hit it again. And now we're going to kind of do the opposite. So you'll see what I mean. Just so you guys know, this is kind of what we're doing. Maybe you remember this. But it was when you had to take something like 5r plus 25 and you had to convert it into something that looks like this. Remember the GCF went on the outside and then it was r plus 5. Remember that? And the distributive property actually says you can multiply the number on the outside by each term on the inside and then get back to that. Okay, but if you don't remember, we'll go over it now. Okay, it's page 16. Page 16 is where we're at. So go ahead and go to that. Okay, your learning target on there again. Now, the distributive property might be the most important thing you learn. Well, it's not the most important thing you learn from me, but this property right here is so much. It's used so much from this point in your lives. You're going to learn it a little bit better next year as far as you're going to go a little bit more into depth in using it. But once you learn it in 7th grade, you will use this property for the rest of your math lives. And that goes for if you go all the way to calculus or whatever class you're in, you will use the distributive property. It is that important. Okay? Now, we got to understand there's two things we got to know. There's expanding. Well, that's what we'll talk about first. There's expanding. Okay, now expanding is actually the easier one in my opinion. This is the one we didn't do early in the year. Expanding is the real purpose of the distributive property. And what expanding is when, like I said, you're given this expression, 2 parentheses r plus 8. What this means, and please write this means 2 times the quantity. I don't know how to spell. I think it's ITY. Yeah, it is. 2 times the quantity of r plus 8. That's what it's saying. It's saying it's 2 times whatever r plus 8 is, and quantity just means the amount, okay? Whatever it is. So you're just multiplying whatever r plus 8 is. That's why it can't be just written as 2r plus 8. Okay, it's totally different. This is totally different than this. Okay, 2r plus 8 means 2 times r and then add on 8 because following PEMDAS. Whereas this, you must do the r plus 8 first and then 2. Okay, and I guess this is like what it means right there. It just means there are 2 groups of r plus 8, which is the same thing I just said essentially. Okay, what the distributive property is, and this is the way you'll use it for the rest of your life, is when you're multiplying an amount by a quantity, something in parentheses, you can distribute it. And basically you can take it and you can multiply by each term on the inside there. Okay? So in other words, you would do 2 times r like it's showing here, and then you do 2 times 8. Okay? And you'd be left with 2, remember 2 times r is just 2r, plus, and then 2 times 8 is 16. That simplifies to that. Okay? Whereas if you guys will remember, in chapter 2 or 3, you guys did the opposite. You took this, remember, had to find the GCF, which is 2, and then you had to think, okay, what would I multiply 2 times to get back to 2r? Well, it would be just r. What would I multiply 2 times to get to 16? Well, it would be 8. So now we're doing the opposite, I guess. We're expanding. We're actually distributing it through. Okay? Let's go down. Okay, again, here this just means 3 groups, essentially, of k plus 6. That's what it means. 3 times k plus 6. 3 times the quantity k plus 6, or the sum of k plus 6. Okay? So you're going to take it and you're going to distribute it once again. You're just going to multiply it. When I say distribute, let's all write that. Distribute means to multiply by each term. Okay? You should know that word term We've been working with that forever. This chapter, okay? You just multiply it by each term. So 3 times k is simply 3k. 3 times 6 is 18. So that is what expanding means. You're taking this and you're expanding it into this. Okay? I can see this box here, what they did here. They're just showing you that it means 3 times k plus 6. It's actually pretty cool here what they did. Take a look at this for me, please. They took it, and what they're showing you is that it's just k plus 6 plus itself 3 times. You see what I'm saying? I mean, that's what multiplication is, just repeated addition. So if you wrote it as k plus 6, k plus 6, plus k plus 6, then again, you could look for common, or I mean not common, but like terms. And that's all you're doing. You're combining like terms. You're taking your 3k's, kangaroos, and then you're adding your 18 constants. That's it. So that's all you're doing when you're distributing. It's actually pretty cool this is actually pretty neat. Until this year, I've never really thought about it like this. So it's actually kind of interesting. Okay. So let's go down and practice expanding. Go ahead and you guys do, you know what? You guys do all 6 of these. I think you can handle that. Go. Okay. All right. So we got to distribute it through that 3 through. So 3 times x would just simply become 3x. 3 times, and you can start thinking of this as positive 4. 3 times positive 4 would be positive 12. Okay, pretty easy there. It's 3 times x, 3 times 4. Here, okay. Notice on here real quick, there's a 1 in front of there, so that's technically 3 times 1x. So it's 3 times 1, which is 3, and then you put on your x. So that's kind of where this comes in, where that coefficient kind of causes a little bit of a problem maybe for some of you. I hope not, but it may have. That's 6 times 2x. So you're taking 6 and you're multiplying it times 2x. That means you have 12x. You have 6 times as many x's, is what it means. Okay? And I do want to see these arrows when you guys do them. 6 times 3 would be plus 18. Okay? We distribute here. 2 times 7 would be 14 plus 2 times 6x, you just multiply it by the coefficient, which is 12x. Okay? Essentially, think about it. You're just doubling each term. You have, instead of having 7, you have 14. Instead of having 6 x's, you now have 12 x's. You just doubled it. You multiplied it by 2. Okay? Okay? Here we go. 5y. 5 times y is just 5y. Minus 5 times 3 would be minus 15. Pretty easy here, guys, I think. Okay? Distribute. It's going to be 16y. 1 times 4 would be minus 4. And just so you know, you should know why you can't combine these two terms. Some people want to say, well, why can't I put the answer 12y? 16 minus 4 is 12. Because they're not like terms. If this had a y on there, then you could, but they're not like each other. You can't just combine. You can't do subtraction before multiplication, essentially, is what's happening there. Okay? So that's the deal there. Okay, this last one here, 9 times 5x would be 45x. And then you'd multiply it by 2, minus 18. Whoop, forgot my x. Sorry about that. Pretty easy there. I don't think there's any real problems there. State whether this is actually learning target number 7 right here, so you can write that on your paper. We do have notes for 7, but may as well just kind of do it now, just to maybe get a jump on things. You got to see if they're equivalent to each other. So you either got to factor this or you got to expand this. I think expanding is easier, and I think you guys do too. 6 times x is 6x. 6 times 5 is 30. Are they equivalent? Absolutely yes. Okay. Here, we distribute. Okay. That's going to become 7x plus 21. Are they equivalent? I'm going to flip back here for a second. Remember this? Commutative property. 4 plus 3 is the same as 3 plus 4. Okay? So going back, this is no different. Just because 21's on that side, you can flip-flop addition or multiplication. You can never flip. If this was a subtraction sign, this would be wrong. You couldn't do it. They're not the same. Okay? Okay, here we go. Let's go ahead and expand this. So here we go. 4 times y is 4y minus 16. Are those the same? No, obviously not, because the coefficient's the same, the variable's the same, that term's the same, but this is subtracting 4, where you actually are subtracting 16. Okay, here we have 3y minus 18. Okay, I'm just doing 3 times y and 3 times 6. Are those the same? Absolutely not, because you cannot, going back here again, this works for addition, the commutative property of addition. There's also a commutative property of multiplication. There is no commutative property of division or subtraction. 4 minus 3 is not the same as 3 minus 4. Not the same. 4 divided by 2 is not the same as 2 divided by 4. Okay, they're not even close to being the same. So you can't do that. Okay? Let's go ahead and go to the next page. Alright, now we're going to do something called factoring. This is what you actually did earlier in the year. This is the one that you guys didn't like. But hopefully you remember. Okay? You have to factor it. So the first step is you have to find the GCF of the two numbers. Remember? This is how we did it. So if you're somebody that's not as good with your math facts, you may have to come over here and do the GCF method, which I go over it every single Friday, so there's no reason to not know it. You stack your two prime factorizations. You look for common factors. I see a common 2. Therefore, I know that my GCF is 2. The GCF always goes out in front of the parentheses. And then I always just ask myself, I say, what could I multiply 2 times to get to 2y? Well, it would be just y. Okay? What would I multiply 2 times to get to 10? It would be 5. This is factoring, turning it into that. And what's great about this is you can always check it. I mean, that's what's cool. Just go ahead and do it. 2 times y would be 2y. 2 times 5 would be 10. Is it the same thing? Absolutely. Okay. Now, just so you guys can just kind of put an X through this. Okay, we kind of do our GCF here a little bit different than the way they have you listing out the factors and then picking the largest one, which is how they got 2. I just assume you guys just do the prime factorization, okay? Okay. Let's go down and check out another one here. You can see, oh, that's them doing that work. So they took out the common factor of 2. That's why it's called factoring, because you were technically factoring out the GCF. I mean, that's what you're doing. You're taking the two terms there, and you're saying, what factor do they have in common? And you're basically dividing that factor out. I mean, that's what you're doing. Okay, so that's called factoring. Okay, I'll do a couple, then I'll have you guys do a couple. So I look here and I say, okay, I got to figure out what the GCF of 3 and 3 is. Well, it's pretty easy. If they're the same number, it's got to be 3. Okay, so then I got to ask myself, how could I get to 3x here? Well, I'm going to put an x there. 3 times x is 3x. How would I get to 3? I would multiply by 1. 3 times x is 3x. 3 times 1 is 3. Here, again, maybe you need to go up. Maybe you're not as good with your math facts. That's okay. You need to go up and actually find your GCF. Okay? Remember, we stack our prime factorizations. We look for common factors. I see common 2's. I see nothing else in common. That means my GCF equals 2. Now, what would I multiply here to get back to 4x? 2x. Okay? What would I multiply here to get back to 6? Be 3. So the answer here would be 2 parentheses 2x plus 3. Okay, that's kind of how you go about it. So I'd like you to try 13, 14. Actually, yeah, just do 13 and 14. Okay? All right, hopefully you did them. Hopefully you got them right. The GCF of 8 and 6 here I know is 2. You could have found that by doing prime factorization here and done your GCF that way. Now, what would I multiply 2 times to get back to 8? That would be 4. What would I multiply 2 times to get back to 6y? Well, I know it's going to be y, but how many y's would actually I need? I'd need to do 3y. Okay? This one here, I know that the GCF of 5 and 10, I know that it is 5. And since that's a minus, I'll go ahead and put that in there. What would I multiply 5 times to get back to 5y? Well, I know it would just be that, right? And then what would I multiply 5 times to get to 10? Would be 2. Okay? This is factoring. We've already done it in the year, so You know, this should be review, I hope. I'm sure, I mean, this was hard at the time, so I can't imagine it being easy now, but at least hopefully you're going, oh, I remember that. Okay, the GCF of these two is 2. Okay, what would I multiply 2 times to get back to 4? 2. What would I multiply 2 times to get to 10z? It would be 5z. Okay? And that is it for the Learning Target number 6 video. Good job, guys.